joining us today in your throngs in this very special event. My name is Tom Freeland. I am a lecturer in the oral communication program at the Center for Teaching and Learning. And I'd like to take this opportunity very quickly to remind you that if, at the conclusion of this wonderful talk today, you are inspired to work more on your communication skills, we in the oral communication program stand prepared to support you at every juncture. It's a simple matter to set up an appointment for individual coaching with a member of our program and build on your communication skills. For today, I have the honor and the great pleasure of introducing to you our distinguished guest speaker, Jean-luc Doumont. I had the good fortune, actually, of hearing him speak a few years ago when he visited Stanford, and I had no trouble finding the notes that I took from that talk because I go back to them again and again and again. There is scarcely a week goes by that I do not share with my students some of the tips and ideas I learned from his talk, and with proper attribution. His insights into clear communication, especially in scientific and technical fields, have been extremely useful to me ever since I first heard him speak. So I have no doubt you all will find these tips just as useful as I have done. Now, when I speak of Dr. Doumont's visit to Stanford, I should really say his return to Stanford, because he received his Ph.D. here in applied physics after completing his studies at the Louvain School of Engineering. He maintains a very busy travel schedule, speaking at conferences and in both professional and academic institutions, some of which you may actually have heard of. In addition to Stanford, he has spoken at UC Berkeley, at Caltech, MIT, Harvard, Johns Hopkins, Northwestern, you get the idea. He is also much in demand internationally and can address audiences not only in English, but in French, in Dutch, and in Spanish as well. This does set him apart a little bit from other presentation trainers. What I find most impressive about his approach to presentation coaching is he also speaks engineer. Now, most presentation coaches, such as myself, come from a humanities background, so this is a bit different. So Jean-luc not only speaks to scientists and engineers about improving their communication skills, he speaks as a scientist and an engineer and demonstrates what clear, compelling communication in these fields can be. He is, of course, a multi-platform presence. He has published a book, Trees, Maps, and Theorems, and a copy is being passed around for people to look at and get your lottery, your raffle ticket for it, if you've not already done so. He also maintains a really useful blog on the website for this book that's regularly updated with tips and ideas on communication. He also contributed a series to nature.com on English communication for scientists, and of course, he's on Facebook. So, without further ado, allow me to present to you a very engaging and rational mind, Jean-luc Doumont.
Thank you, Tom. Talk about raising expectations. Goodness. You know, everyone, pretty much everyone, has got a fascination for science and scientists, somewhere deep inside. If you look at pretty much any type of fantasy story, books, movies, comics, you will find that there is a fundamental role in there for one scientist who is going to invent whatever is needed for the rest of the story, invent it technologically or possibly magically in some cases. So it looks like most everyone's interested in that. At the same time, the image that people have of scientists are sometimes a little surprising or discomforting for those of us who feel we still belong in science. Now, I grew up in Belgium, so my main reference source would not be movies, it would be comics, high-quality comics. We are the country for it, and maybe the most classic comic series in Belgium has recently been more popular in the United States since last Christmas, basically, because someone made a movie out of that. It's the Tintin series. Now, the scientist in there did not appear in the first movie, The Secret of the Unicorn, but I bet you it's going to come soon enough in the sequels to that series. And that scientist is this little guy right here. So the first question to some of you, if you are a researcher, can you identify with this up front? But that's very much the image we have. It's not just that series. Everywhere you look, and that's the whole of my childhood, looking at all those scientists, there is something about them that is surprising. Now, that is French-speaking Belgian comics. This is a Dutch-speaking Belgian comics right here. Most of those are actually inspired from real things that happened in Belgium. This is the Solvay Congress, where you recognize people like Albert Einstein, Marie Curie. And in fact, this guy here, Auguste Piccard, was the inspiration for Professor Calculus that you have there. So this person also looks very much the same. If you go to France, you'll have slightly different versions of the scientists. But if you look at it, it's basically the same idea. What does that mean? Well, all those scientists, they are usually a little weird. Things happen to them, they're just not like everybody else. And in their weirdness, they may often be a little dangerous. And you get at least the main character of the comics with a lot of common sense, trying to prevent scientists from doing well-meant but totally disastrous mistakes occasionally. So that's very much what you see in there. Have you noticed how all of these scientists look? They are all old, white, males, with a lot of facial hair, typically. Long beards, or at least incredible mustaches like you have here. And it's not just the Belgian approach to it if you go to other countries. This is basically the same idea of the scientist, the guy who has it in him to solve everything that the other people cannot solve in there and supply whatever is necessary technologically, like some things to go back in time and so on. It's basically the same picture. Now, it's true I exaggerate just a little bit when I say they are always white. It's not true. Sometimes they will be blue as opposed to white, but the idea remains it's an old male somewhere in there. Now, there have been a number of attempts to break that a touch, and some have been more successful than others. If you want another very classic and highly respected Belgian comic, this was the scientist in there. So at least you see he's a lot more action-oriented than many of the others. And it's a little younger too, but he's still a male, a white, and he's got facial hair and everything. And the same goes for other things that went in there. This is American as opposed to European. So he doesn't have a beard or a mustache, and he's also a little young, but he's also very weird, right? Very, very outside. There have been stronger, bolder attempts, which sometimes are such of a caricature that the resulting character is not believable anyway. Perhaps my favorite one, which sets the balance a little better, is also a Stanford alumna. That would be this person here. But also in the movie, if you watch Avatar, you notice that there are things that sets the person apart, like she's a chain smoker. She couldn't be a normal person. She's got to have something psychotic about her to be a scientist, basically. It is all over the place. If I go back to my original one here, there is something else that is extremely interesting about this prototypical scientist that I think has been the model for many others. Anybody knows this character and can tell me what's typical about him? He would be very offended if you said to him he's deaf. Because in fact, he maintains that he's just a little hard of hearing on one side. But practically he's deaf, yes. Basically, he's unable to communicate. That's what it is. The prototypical scientist in the stories that so many countries have been reading from and has been taken inspiration from is someone who cannot communicate. And that is, in fact, the image that many people have about scientists. You wouldn't believe how many times I get comments about it myself when people say, wait a minute, you're an engineer, and you got a Ph.D. in applied physics, and now you do communication? I don't think so. It just doesn't fit for people. Maybe one thing we had to try to see in this presentation is how can we change that? How can we make scientists look like you guys in this room, which means normal people who do very interesting things and so on. That's what I propose we do in this presentation in 3 steps. One is to try to see where that comes from. Why do we have this reputation, perhaps partly or fully deserved, of not being the champions of communication? If we understand that, we can already change a number of ways. Now, why is it particularly hard to talk to non-scientists? Well, there are specific challenges. There are always challenges, but for non-scientists, they are a little harder. Let's look at that, and eventually, of course, what we can derive from that, well, we'll do it all the way through, but in a third point, a little more systematically, let's see if we have strategies. Now, across all of this, and to make the link to what Tom was saying about my other presentations, I have approached communications in many different contexts. Scientists talking to other scientists, scientists talking to lay audiences, business people talking to whoever you can imagine, all in the different ways. And now I know it's a view of the mind. Some people look at differences, some people look at similarities. But if you ask me, I would say fundamentally all of that is the same. Sometimes the situation makes it a little harder, but it doesn't mean it's another situation. If we go high enough, we can find basic strategies that in fact apply no matter who you talk to. Well, you'll have in the details to be slightly different, but at least I think pedagogically, I think it's more useful, it helps people more to say, let's focus on the fundamental similarities instead of focusing on the superficial differences. Yes, in the end, a text for non-specialists and a text for specialists will look different, but the effort to go there, the intention, is in fact very similar, as we will see. Now, why can't we communicate? Or is it true that we can't communicate? I can't resist telling you a story. This is a lecture, but what I mostly do is train people like you in small groups for much longer periods of time, either a half-day, full-day workshop, even longer training programs. And on the first day, I asked the 25 PhD students typically in front of me to say something about their research as they introduce themselves. They have to say their name, something about their research, and so on. So 25 people do that. They are all from the same school. And afterwards, I asked the group, out of those 25, something about the research, how many did you actually understand? Now, they are all from the same school. You would expect that number to be 100%. In practice, it is never higher than 50%. It can even be much lower than that. It gets worse. Because then I also ask them, well, you've heard all those research topics. How many actually got your attention? How many times did you go, wow, that sounds cool. I wish I could do that instead of what I'm stuck doing in my own PhD. Well, in the best case, the answer would be 1. Conclusion, when people like you talk about their research, half of the time, even your peers don't understand what the hell you're talking about. And when they do, they find it boring. That's the sad truth. Now, we can learn something from that, of course. What do we observe? What do I observe systematically when I do that kind of exercise with my training participants? Well, several things. First, what is striking is the use of vocabulary and delivery. Typically, they will use lots of technical terms, difficult for the rest of the group to catch, less usual. And whenever they say a technical term, they will lower the volume of their voice and speak faster, which is basically confessing that they know deep inside no one understands or no one cares. So they're trying to get that over with as fast as possible to bother people as little as possible. That is not exactly a strong will to communicate. That's the first problem. Second problem you notice, and the reason why it's boring, is that they misunderstand my question. They always do. I just ask very vaguely, say something about your research. They could say anything, but they understand my question to mean, what do you do? And if you say what you do, that's always boring. People say, well, I try to optimize the recovery of this specific compound in the wastewaters of that industrial process. And if you say that, everyone goes, uh-huh. Well, good for you, not for me. What's missing? Simply, why do you want to do that? Why is that a good idea? Why is that worth your time? Why is that perhaps worth the money that somebody is giving you to do that? The motivation is often missing. Now, where do we learn that? Where does it come from, the fact that we indeed don't communicate very well? Because to tell you the truth, it's true that scientists cannot communicate very well with non-scientists, but in fact, they can't communicate very well with other scientists either. Go to conferences. When I ask people, how many talks did you understand? It's usually no more than 25%. How many talks did you actually find interesting at the last conference? 8 hours a day, 5 talks an hour, 7 days in a row, that's a lot of talks. If they have one talk that they remember, it's a lot. So the problem is really deep. Where does it come from? Easy, good news for you, it's not your fault. If you're a PhD student, a postdoc, or even a professor, Where have you been all your life? In school. And school is the worst place where you could possibly learn communication because it's the wrong purpose and the wrong audience. When you communicate in school as a student and they tell you it's important, well, the only way they have to tell you it's important is to say it's going to be graded. Which means the audience would be an instructor, a professor, a teaching assistant, whatever, someone that you regard as knowing the topic better than you do. So you see the problem here. We are learning to communicate by explaining things to people who already know them. What kind of a learning experience is that? It's just the wrong approach. On top of that, the purpose is being graded, which means we have to prove to those people grading us how clever we are. And that's also putting the wrong focus in communication. And then we're surprised to see young PhD students who go to conferences and they try to do the same. They're trying to prove to the entire world how clever they are, how complicated their research is, and the sad news is the world does not care. They don't want to know if it took you 6 days or 6 weeks or 6 months or 6 years. They want to know if it's important, if it's relevant, if it's applicable, that kind of stuff. And we learn the wrong purpose. We learn to try to impress people, to try to show off our knowledge in a situation in which we have, in fact, no other reason to communicate than being graded. So that's another reason why people never give motivations when they talk. They talk because the professor told them they had to talk on a topic. There was no reason to talk about that topic. They do because they are asked to do it. That's also something you find in the reflexes that people build afterwards. They go to a conferences. How do they start a talk? Do they try to motivate the audience about the research they've done? No. They do it in a very school-like way. They have a slide with their name and the title of their talk, and they say exactly that. They say, well, so yes, good afternoon. My name is blah, blah, blah. And I'm going to talk today about, and then they read the title of their talk. This is just the way you had to fill out the top of your exam sheets, right? You had to give the name of the course and your name, and we learned that from all of there. So that's a big, bad school to unlearn in order to do something else. It's deep in us, and that's a big focus on training programs in general, is stop doing what you have built the successful reflexes to do. We need something else. We need something else to talk to peers. We need something else to talk to non-scientists. And for non-scientists, it's just a little harder. Why is that harder? Well, let's look at 3 things. First, distance problems, then reasoning problems, and then process problems. If you want people to learn something, and you know that, if any of you is doing any teaching, you have been taught that or you have discovered that, people can only learn something new if they can relate it to something they already know. That's the only way. They can pretend to learn if you give them something out of the blue, but it's not going to stick. In that category, for example, in one university in South America, I had to tell them, if you want to send people to my writing class, don't send first-year PhD students. If they have not tried already to write a paper and had the paper rejected, they don't have enough reference points to really learn what I'm teaching them. They're going to say yes, yes, yes to everything I say, but it's not deep in there. So this is a prerequisite. Now, you see the problem here. You talk to peers, they are close to you in knowledge space. They know what you're talking about, to some extent at least. You talk to scientists from another discipline, that's more difficult. You talk to non-scientists, they are even further away than that. And so there is a big job, if you want to talk to non-scientists, in bridging the gap. Well, there's always a need to bridge the gap, but the gap is bigger. This is something that is often even misunderstood in simple things, in presentations. I and many other people would recommend, if you give a talk, that you have a so-called attention getter, to get the attention of the audience so you can have the attention when you say what the problem was that you're working on, you motivate them. And then in the first learning step, we are just happy if students have an attention getter at all, let alone an appropriate one. But what people often misunderstand is not just shouting, hey, pay attention to me. The truth behind the attention getter, or the deep way to think about it, is to say, it's a bridge. The attention getter is starting from something the audience knows well, cares about, and then making the bridge to where you are. So it's got to be audience-oriented. That's fundamental. It's not just, I'll do anything that will make them look up from their sheet or stop talking to their neighbors to look at me instead. There's something else in there. There's building this relation with the audience. Start from where they are. They are non-scientists. Well, you have to start further. That means you have to know where they are. Rule number one of communication, the most obvious, and at the same time, if you ask me, the most difficult in practice, is just adapt to the audience. Take any book on communication or just about, you'll find something equivalent to that. Adapt to the audience. Well, you have to know who your audience is, otherwise you cannot adapt. Just to give you a short anecdote why, or an example of how it's so hard to adapt to the audience. A silly thing, but I'm in the middle of it right now. When I run longer workshops, I want to learn the names of everyone in front of me, and that's lots of people in my life. So I asked these participants to send me in advance a picture of them, so I can learn who is who in advance. So they sent me an email with a JPEG file in attachment. Can you guess how they name that JPEG file? JPEG 1 is a good guess. DSC 06155 is not a good guess, but often it's a lot more self-centered than that. It's me.jpg, or sometimes they even use my name. It's Doumont.jpg, because for them, in their logic, it's the picture for me. But of course, that's just a sign they're not thinking of the situation I'm in. Imagine my whole hard drive filled of photographs that say me.jpg. That doesn't help much. So this is just so simple conceptually and so difficult practically to put yourself in the shoes of the other person. But that's a very first and a very important step. Figure out where they are, go back there, and then bridge this gap. If you start midway, it falls through. You don't have a bridge. People are never going to come to your topic, in a sense. That's the first point. Second point. One day, I hope I will get the chance to write this book I have in mind that I'm going to title Everyone's Favorite Mistakes. Because I keep hearing logical mistakes all over the place, from scientists a lot, I must say, but even stronger so for non-scientists. And that is something you really have to watch when you communicate with them, and possibly take a number of precautions compared to that. What are the favorite mistakes? But let me mention just 3 of them. First, confusing the ends and the means. Example. Years ago, when I had another business partner, we had offices in a building. There was a cleaning service for that building. So every Tuesday morning at 8 o'clock in the morning sharp, someone would come and clean my office. I realized that in the middle of the winter, when it's still, in Belgium especially, it's very dark outside at 8 in the morning, she would not even switch on the lights to clean my office. And I thought, well, that doesn't make much sense. What's the whole idea? Well, that's because naively I thought that the whole idea of a cleaning service was to make sure that afterwards my office is clean. Not so. That's an objective. They were not working by objective. They were working by method. So they had a sheet that says every first Tuesday of the month you have to clean, well, not clean, you have to take care of the windowsills. That means you have to go over them with a slightly wet sponge. If they were already clean before, you still have to do it. If they are still dirty after you've done so, you don't have to do it a second time. Because the procedure just says that first Tuesday of the month, you pass with a slightly wet cloth on the windowsills. That's working by principle, by procedure, as opposed to working by method. And that's a big difference that people often don't get. Here's a real case example. The Louvain School of Engineering at some point changed its approach for teaching. And that got totally misunderstood because they were confusing ends and means. Now, you have to know that in Belgium, we've got 2 engineering degrees. And of course, there's a big rivalry between the 2 and a big fight. There's what we call industrial engineers, those who are a lot more practical, a lot more the hands in the grease, in a sense, about building things and so on. And that's not taught at universities. It's taught at what we call higher schools, but it's not university. Then there are the university engineers who tend to be a lot more conceptual. That's the whole idea. Not necessarily more theoretical, but at least conceptual in their approach. Now, those university engineers, they had been, for 6 centuries, they had been taught in the same totally inefficient way, which is lecturing. You know, that's because it's a university that was invented created in 1425. Gutenberg was just born, but did not invent the printing press yet. And so the approach is very much pre-Gutenberg. One day they decided, let's change that. Let's do problem-based learning. Give them a problem, make them work on that so they see the motivation for the theory that we want them to absorb. Now, the newspapers, when they heard that story, they misunderstood entirely. They said, and I remember the article, well, since they are going to teach in a very practical way, then there is no difference anymore between those university engineers and the industrial engineers, right? And then the dean had to write a letter and say, well, you missed it entirely. What is much more practical is the teaching approach, not the end knowledge, skills, attitude that we're trying to develop. In the end, we want those engineers to be the same, only better, but the way we get there is more practical. Not the material, the approach. But we realized that the journalists just didn't get that. They were confusing the needs and the ends all the time. That's a big, big issue in communication as well. You know that my biggest enemy when I try to teach people like you how to communicate better, that would be your boss, your PhD advisor, your group leader, trying to undo everything that I'm trying to do with dogmas. And dogmas are another typical example of confusing the ends and the means. They say, well, you have to do it in this way. And the approach that I have is always to go, I'm a physicist after all, and go, yeah, why? Keep asking why, you know. And if you have an objective, you change your view. I think someone, yes, that must be you right there. No? Yes, you in black. Yes, the third switch, the second from the left. Yep, that would be it. Thank you. There we go. Procedure, yes. So those PhD advisors usually say, well, that's the way to do it because everybody else does it or something like that. And they end up having these discussions, well, what should you put at the beginning of a talk? Should you put this? Should you put that? Let's see what people think. And the question is not that. The question is, what are you trying to achieve at the beginning of a talk? Well, you're trying to get people's attention. You're trying to motivate them to listen to the whole presentation. You're trying to establish credibility. Well, once you know what it is you're trying to reach, the end, then you can discuss the means, but not something in between. And so Tom told you the book is circulating. I have now, because of that frustration, written a little booklet. That's a free PDF download if you're interested. It's about very much the confusion between the ends and the needs, or why people who listen to me and agree with everything that I say feel that they are not allowed to do that in practice. You know, my boss will not like that for some reason. Think objectives and help also the people you talk to, especially non-scientists, to make this distinction. This is not what we want to do, what we want to reach at least. This is what we want to reach, and this is just a means to go there. That's the first typical mistake, confusing ends and means, confusing objectives and procedures, things like that. The second, perhaps the worst one if you ask me, is confusing necessary conditions and sufficient conditions. And that's something that starts when the kids are in second grade or something, when you start telling them that all squares are rectangles, but not all rectangles are squares, because there are more conditions to be a square than conditions to be a rectangle, and so on. There's something also the primary school teachers tend to confuse, if you ask me, or if I see my kid coming back from school saying, well, the teacher said the opposite of what you said about it. And that's deep-rooted. I remember a friend of mine, an engineer, mind you, somebody trained, who once had a problem of tooth decay inside a tooth. So basically, no amount of toothbrushing and flossing or whatever you do could have prevented that. That's just the way it happened. She concluded from that brushing your teeth was useless. See the problem? She was still brushing her teeth, let me reassure you. But intellectually, she said, well, it doesn't serve any purpose, does it? Because even if you do it, you can still have tooth decay. Well, that's confusing something necessary and something sufficient. It's not sufficient to brush your teeth. That's not a guarantee of not having problems. But it's still necessary, a necessary step if you want to prevent tooth decay in general. But she was very much in that mentality. She would also, for that reason, do a lot of interpretation, which is usually confusing the causes and the symptoms. She would write a letter to a client of hers, and then that person would not answer, and she would write a second letter saying, since you have not received my first letter, I'm sending you this reminder. And every time I would talk to her, I would say, well, you can't say that. You don't know whether they received the letter or not. And she said, well, they haven't answered. If you receive a letter, you have to answer. So if they did not answer, then they did not receive my letter, right? And I go, wait a minute, there may be a million other reasons why they're not answering. They don't like you, perhaps. They don't have time. They don't, lots of reasons. You cannot draw that conclusion. That's confusing, necessary and sufficient condition. Now, if you look at vulgarized literature, popularized science, you will see that the mistake is done all the time. And my favorite place where to go and look for that is commercial advertising, when they confuse the symptoms and the causes. The worst I've seen was in one of those airline magazines. It was a commercial for artificial hair implant. For some reason, you always have one of those advertisements in airline magazines, don't ask why. But anyway, these people were stating what I believe is a trustworthy correlation. They say there is a correlation between being bald and having cardiovascular problems. And one possible explanation of that is that if you don't have enough blood circulation in your scalp, that may lead to faster hair loss. In any case, those people were concluding, given this correlation, they were saying, do not take any risk with your heart. Have an artificial hair implant today. And I go, wait a minute. That is taking the correlation in reverse and confusing correlation and causality, right? The usual way that you have about that. But you see that a lot with non-specialists, non-scientists, which means, if you want to look at it in a different way, you may have heard in your math classes about contraposition. If A implies B, then non-B implies non-A, and not the other way around. But even scientists get that one wrong very often. One thing I often say about graphs, and when I show a pie chart with a third dimension, something in perspective, and we criticize the third dimension as being meaningless and distorting the perception you have of the data, I end up saying, well, if you do not have 3 variables in your data set, do not put 3 dimensions in your graph. These people understand that to mean if you do have 3 dimensions in your data set, 3 variables, put 3 dimensions in your graphs, which is incorrect, of course. I would not recommend very often to do a 3D graph. That's a very difficult to perceive graph. So all I'm saying is if you don't, then you don't. And that doesn't mean if you do, then you do. But see around you, if you have non-scientists, that's a very, very frequent mistake. So you have to take precautions. If you say, if you don't have 3 variables, don't put 3 dimensions, you may want to add immediately after that. Now beware, that does not mean that if you do have 3 variables, you have to use 3 dimensions, just making sure that you have one thing and its opposite in a sense. That's the second one. So we had confusing ends and means. This is confusing necessary and sufficient. The third one is just the total lack of perception in most human beings about variability. Our brain was not designed to think statistically. Our brain was designed to think about certain facts. And we don't handle variability very well, a little better as scientists than non-scientists, but still, favorite trick I play on some audiences in a specific workshop is I ask them around the table, please tell me how long it takes you to commute, to go from home to work. And after that, I criticize the fact that all of them answered my question with a single number. That makes no sense. You have to give me at least 2 numbers, either a mean and a standard deviation, or a minimum and a maximum, which is probably even a minimum and a maximum of the reasonable zone, outside of which you could still have outliers if there is a strike of the public transportation, what have you. So one number cannot be the answer to that, but we seem to think only about certainties, which is why I believe people are pretty much always late. Why are we always late? Think of it. The travel time to anywhere, from the office to the meeting room is the same. This is a Gauss curve. People, first of all, in the best case, aim on the mean, which already means that they are late half of the time. But usually, if it takes them 5 minutes on average to go to the meeting room, and on a specific day it only took 4 minutes, that is somehow their new psychological mean, and from there on, 4 minutes is what they take, and so they are late 75% of the time, and so on. We don't think of probabilities. We don't think we might meet a colleague in the corridor and have even a 2-minute chat, which means we are even more late than we were before that. Variability in general, which of course translates in people's very poor perceptions, especially lay people, of probabilities. You tell them, oh, there's no danger living next to a nuclear power plant. The chance of getting cancer from the radiation would be 1 in a billion. Very low. Many of you would say, oh, yeah, well, that's indeed much lower than I thought. But lay people will say, oh, you mean there is a chance? You mean it could be me, the 1 in a billion? Well, yes, it could be you in a sense. They don't have a sense of probability. You will have to compare that. But even in comparison, then you have to watch the fact that many people have this illusion of control. You tell them, okay, let's do it in a relative way. The chance of getting cancer by living next to a nuclear power plant is 1,000,000 times lower than the chance of getting cancer by smoking. Even that will not do the trick, because they will say, but smoking I can do something about. I can quit smoking if I want. In fact, they don't want and they don't quit smoking, but still they've got this impression, yes, but that I can do something about. Isn't that the reason why everyone is so scared sometimes of taking the plane? In fact, I travel a lot. I feel safe in the plane. I have found out firsthand that the big danger is the taxi driver from the airport to the hotel. The plane is safe, but when people drive, they feel they're in charge. One statistics I love about this country, in the United States, it has been reported once, 75% of the drivers feel that they drive better than average. Which would be just possible if you have a probability distribution with two humps, and then that would work, two peaks. But if it's something symmetrical, like a Gauss curve, not a chance, of course, because the mean is also the median, and then you'd have 50-50. But that's the impression we have. So be really careful if you talk probabilities with lay people, because they don't have a good grasp for that. Now, beyond this faulty reasoning, which I personally think is the major issue when you want to make them understand something subtle, one challenge is also the lack of control that you may have. You publish a paper, you've got peer review, you've got advice, and you can check the proof, the real proof, before it's published. My main concern with journalists, whenever they interview me for things like that, is whether or not I'll have the chance to see what they write. Because even with my best explanation, they could misunderstand what I say, and if I have a chance to check, then I can fix things. Now, they don't like that. They feel like I want to mess with their text. And so I have to ask very, very carefully, very humbly, saying, well, not that I want to rewrite anything at all. It's just, in case you might have misunderstood something I said that I tell you. And in practice, I sometimes want to change a lot more than that, but that's a problem. Give yourself the means. If you ever have to do that kind of communication with the lay audience through somebody else, like journalists, like media, like reporters, like magazines, see if you can check. Even when you check, you have surprises. I've been publishing in scientific magazines, not journals, lately, and I had been shown a proof. I had fixed a number of things on the proof. They still changed things that were against my recommendations in the final text. And I was saying, well, if any of my training participants sees that, my credibility goes down the drain because I tell them not to do exactly that. So it's still a limited thing, but see if you can have some control in there because, you must have played those games in school when someone says something to someone else who says that to someone else and so on. You see what's left of the story at the end. Well, even with scientists all the way along the chain, you'll have losses. If it's non-scientists who mean well but may not have the same conceptual basis, it's getting harder. So what do we do about all of that then, given that it's difficult? Well, let me give you three main tips with the details. First, one biggest issue that people have if they're not scientists is the lack of reference points. Second, as you have mentioned, is a vocabulary issue, and we can talk about motivations and outcomes. You mention a number to a scientist of your field. That person may hear that number and say, oh, really? Wow, that's impressive. You mention that number to a non-scientist, and the answer will be, so? Is that good? Is that bad? Is that a little? Is that a lot? Are we happy about that? What? They just don't have the reference point. So one thing that's useful for non-scientists is to give relative numbers as opposed to absolute numbers, or perhaps even better, in combination with absolute numbers. And quite frankly, I recommend that a lot for peer communication as well. That you say the absolute value, and then you say somehow this is 50% more than the previous version of the algorithm, something that shows a % increase. That's a very important one. Numbers in themselves will not tell them anything unless you provide a comparison point. It's true also for sizes. They will not be able to picture many of the things that you spontaneously picture. So you may have to give many illustrations, photographs even. Now, a photograph is not the best way to explain a process. If you talk to peers, a schematic might be better than a photograph. But to a lay audience, if only for a question of size, it helps to have a photograph that they go, oh, that's what it looks like, which means the picture needs to include an element of scale. The simplest, if it's a big thing, is to put someone next to it. You be in the picture, they can say, okay, well, that's a human being. That's a really big thing. If it's very small, then you put a small object. A classic you must have seen is putting a penny next to a small thing you photograph. Even that is better than putting a scale. Well, if it's a micrograph, then the only thing you are left with is at least saying that's 20 microns or something. But if you can incorporate an object that they know, a comparison point that's meaningful for them, that would help a lot. That is also true whenever you discuss concepts. What is great for everyone, but particularly so for non-scientists, analogies and examples. Analogies is again bridging a gap, right? You talk about something they know well, and then you say what's exactly the same in this situation, and they go, oh, I can relate that to something I know, I can learn it. I would not be too worried about analogies. I'm a little more worried about examples, especially if you only give one, because again, I've seen many cases of confusion between the concept and the example. They thought the example was what you were doing. They did not realize it was just one instance of something more generic, and that is the concept. So if you can, then the recommendation is give more than one example. And the usual recommendation is to say give 3. If you give 2, then it's still very much an opposition, is that one and that one. From 3 on, at least I've been told so, but it makes a lot of sense to me, people start being able to generate their own examples. For me, 3 is in any case the simplest complexity. So it's the minimum you need in a sense. You could give more, but maybe that's just enough for conciseness. Give 3 examples. Comparison points is the whole idea, meaningful for them. When people explain to me, they give me directions to go to their home, they always use street names. Well, I don't know the street names ahead of time, do I? What would be a lot more meaningful to give directions to go to your house is to use things that people can relate to, can see, like a fuel station. You go to the Shell gas station, and then you make a sharp right, and when you hit a Safeway, then you turn left, and blah, blah, blah. That's a lot more noticeable. It's a lot more in people's knowledge. You can see that from a distance. It makes sense to you. Same idea. Comparison. Second thing, watch your vocabulary. In particular, no jargon. Now, what's the difference between a jargon and a technical term? Well, if you ask me, it's a question of intention, much more than words. So some words, the same word could be in one category or the other depending on how you use it. The technical terms have been invented to be clear for as many people as possible. So you have technical dictionaries. Jargon is just the opposite intention. It's trying to exclude as opposed to trying to include. There would not be dictionaries of jargon up front because the whole idea is if you know, you know. If you don't know, you're lost. Now, if you use what is in fact a technical term, well defined in a technical dictionary, but if you use it knowing that people don't understand it, if you use it in an effort to impress people as opposed to an effort to inform them, then you're using jargon. And in particular, watch abbreviations. Even abbreviations about which people will say, ah, yes, now that you say it, I knew that one. If you don't remind them what the abbreviation is, they will be easily confused. Even in technical fields, I'm confused all the time with abbreviations, even though they're simple ones. Give me the full expression, I understand the concept. Maybe I didn't know you were using an abbreviation for it. Be careful. Now, the other one is the one with which I have the most trouble when I talk to journalists. Any journalist in the room? You know? Yeah, one. So we'll see if we have a fight or not, but usually let me reassure you it's with the inexperienced ones I have problems. It's when I say no synonyms. Synonyms are the best way to lose people. You can imagine when I train scientists, well, my Ph.D. was in applied physics, in optics. I train scientists from all walks of life. So I read a lot of papers that they submit as homework or something. Up front, it's not my field. If it's well written, I can understand the story. And there are words I don't understand. I call that X. I don't know what it is, but I know that X has a bad influence on Y, and therefore they do Z about it. As soon as they use a synonym, I'm lost. Because this thing that for me is X and that thing that for me is T, if I don't know from my knowledge of the field that it's the same, I'm lost. So I tend to say no synonyms ever with anyone, especially not with non-scientists, which is where people from more English departments and the like, more literature departments will say, oh, but synonyms are fundamental, otherwise it's boring. Now, even in that case, I would say, from an analytical point of view, synonyms do not exist. They do not exist. A different word for the same thing would have a slightly different meaning, or at least slightly different connotations. And if you have a good dictionary, you've got those shades of meaning in there. I learned a lot from just the dictionary I have on my Apple computer, which is good enough. Very often when I look up a word, it says the right word, and it gives there 7 or 8 words which I thought meant the same, and explaining why, in fact, they imply different things. So the idea, if you want to use the language, is to say, well, feel free to use what you thought were synonyms, but not in a synonymous way. If you change the word, have a reason. And the reason is not, well, I've used that word 3 times already, I cannot use it anymore. The reason has got to be, I'm trying to introduce a slight nuance here. But beware if it's technical stuff, you are going to lose people. Even ordinary words, if you take international audiences. You are writing a paper that's going to be read by lots of people in Africa, in Asia, and you name it. You say once this paper, once this article, and once this manuscript, not to say this document, they are going to try to look for a difference in meaning in there. Trying to figure out, is that exactly the same or not quite the same? What's the idea? No, synonyms, the good idea. It's applied very strictly with, by people who try to talk to immigrants, people who try to have things translated automatically. Then the rule is no homonyms, no synonyms. One word, one meaning, one word. That's safest. Now, I don't want to push you there and lose the nuances of a language. At the same time, if you realize that a certain use of a synonym would confuse a computer, chances are it's going to confuse a human being as well, more easily than not. So beware. One last story about vocabulary and encouraging you to write simply. In my training program on scientific writing, people have to do a homework. They have to rewrite an abstract, basically, and they send that to my business partner or to myself. We look at that at the office, and then we have individual tutorials with them. And very often, at some point, I will point to a sentence in front of that student, and candidly, I will say, what do you mean here? I didn't get that sentence. And now this student is going to look at me, look at the sentence, look at me, look at the sentence, look at me, look at the sentence, and then heave a big sigh. And then look at the sentence and say, yep, yeah, that's not a very good sentence. But it's difficult. Look, what I'm trying to say here is blah, 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 blah. But I just don't know how to say that. And you can guess what I'll tell them, right? I tell them, well, you've just said it. Now, don't get me wrong. I don't think written language is exactly the same as spoken language. You have to clean it up. But you don't have to write in what so many people think is a separate language, namely scientific English. It's a joke. It's a myth. It does not exist. Write for other people the way you wish other people would write to you, in fact, in particular when you're talking to non-scientists, of course. Write like you would explain to me in the corridor. You wouldn't explain to me orally the way you would write a paper, and that's a pity. You can give me a simple explanation about your research. Well, do the same kind of things in writing, especially for non-technical audiences. Now, the last point is back to my first example. We tend to focus so much on ourselves, on our own work, and we forget to say why we did what we did, and we forget to interpret it at the end. So again, for all people you talk to, but especially for non-scientists, spend much more time, spend perhaps the only time, saying why something needed to be done and what we have found by doing it means. And the details of how you've done it in between is usually only of interest to specialists. So not even every scientist, and usually not the non-scientists. They want to understand the starting point and the end point, in a sense. Focus on the beginning and on the end, skip the middle, which is your favorite part, because that's where you can show the world how clever you are and how complicated it was. Don't try, in other words, the way I see in so many presentations and papers, don't try to make people go through all the pain and suffering you have gone through in your research, okay? Simplify it for them. Skip the hard work. That was your job, not their job. This brings me back to the idea that it's something general. So we know many of the bad habits come from school. We know that the challenges are about distance issues, about confusing a number of things like ends and means, like necessary and sufficient, like probabilities and statistics. And it's about the lack of control you sometimes have on the process of popularizing science. And then the strategies are about comparison points for numbers, for sizes, for concepts. It's about the way you write, writing simply, avoiding jargon, avoiding synonyms. And it's about focusing on what they really care about. This is true for scientists too, and I can't resist putting that in perspective now as a conclusion with this here. This is my recommended structure for an abstract. Show why the field is important, show what the problem is, what you're missing, what you've done, what is in the paper, what you found, what it means, and anything about the future. Works very well. Many people have adopted that, rewritten papers. The paper was rejected, went to accept it just by rewriting it in this way. Unfortunately, what I see most in the literature is focus on what is interesting for the author. What is reader-oriented, context and need, conclusion and perspectives. and that's missing. What you see in most paper, what I have done, me, the author, what I have found, me, the author. Why you should care is not in there. What it means for you is not in there. Let's go through one example at least so you see the depth of the problem. And this is specialized literature, mind you. So imagine non-specialists reading that kind of stuff. Let me read it with you and then we'll see what it means. And I have to catch my breath. Look at this here. Anhydrous calcium phosphate was modified by surface silylation using 3 organosilanes, H3CO3SIR, where R corresponds to the organic moieties CH2, 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 and H2, CH2, 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 and H, CH2, CH2, and H2, and CH2, 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 and H, CH2, CH2, and H, CH2, CH2, and H2, comma, originating nanomaterials named capsule 1, capsule 2, and capsule 3. The products were characterized by elemental analysis, infrared spectroscopy, X-ray diffraction, thermogravimetry, and P31 and C13 nuclear magnetic resonance. The amounts of attached amino groups and surfaces were 0.32 plus or minus 0.05, 0.54 plus or minus 0.04, and 1.21 plus or minus 0.04 millimole per gram for, and this is my favorite part, capsule X, X going from 1 to 3 respectively. What a complicated way to say that. Would you say that orally? Would you talk to someone? Of course not. Suspended cyanized phosphates adsorbed copper captions from aqueous solution at liquid-solid interface. What you have in here, what they've done, what they've found. So it leaves you, unless you are familiar with this field, it leaves you with 2 questions, fundamental questions. First question, when you read what they've done, is simply, who cares? Who in his right mind would actually want to do something like this? Now, don't get me wrong, I'm sure this is very important research. I'm not criticizing the research per se, but there is nothing in there to get my attention. Nothing at all. So this is restricting the scope of the readership so much. Very few people would want to read this. If you choose not to, it's because of a negative decision. It's when you say, well, I don't understand, and therefore I'm not going to read it. You could wish that abstracts would do the positive decision, that you could say, well, I understand all of it. And because I do, I can now decide that this is not of interest to me. That would be positive. So the first question is, who cares? Second question, so what? Look at this here. I think this is meant as the conclusion. Suspended cyanized phosphates adsorbed copper captions. Now you tell me, because I still don't know, is that good news or bad news? Do we want that, or do we want to avoid that? I have no idea. Let's not do this at all. So the idea here, let me insist again on this bridge, and it works for scientists and non-scientists alike. Start from the reader, go back to the reader. If the reader is further away, you have to work harder at the beginning and work harder at the end. But even if it's a published paper, you will have a mix of expertise there. I know I also use scientists and non-scientists as a binary model in my teaching. It's easy to think either these or those, but it's a continuum. Your paper is going to be read by first-year grad students, people who are new to the field. And if you don't think of those readers, then you are reducing the readership. So much of my effort in writing especially is to try to make every single published paper or document useful to more people. I would say it's not either one or the other. It's not, am I writing for specialists or for non-specialists today, because it's 2 different genres, as it's sometimes called. There is something that goes together. You put the absolute number for the specialist, you put the relative value for the non-specialist, and then you put the relative values perhaps first and the absolute number in parentheses, so it's only for those who really need it. Something at several levels would be my recommendation. So let me finish by going back to the image we have of the scientist at the beginning and tell you, if you are audience-oriented, if you really want to communicate, then don't be a deaf scientist cut off from the rest of the society at large. Reach out. That's the main thing I can tell you. You know, my students who introduce themselves say something about their research. You know why they use the technical terms fast and with a low volume? They don't really want to share their research. They're answering my question. I told them to say something about their research. They do because I said so. You want to do this, you have to care. You probably care a lot already about your topic, and that's good. You want to be a good communicator, especially with non-specialists, non-scientists. You need to care about them. You have to love your topic. You have to love your audience. Passion is the key for this one here. All right. I had promised I would raffle a book. You got raffle tickets, but maybe we have time for a few questions first. Yep. Do we have a microphone for questions? Over there. Can we? Yeah. Oh, there was a question. Okay, first question. You second. I'm not forgetting about you. Go ahead.
Thank you. Excellent presentation. How do you cater to mixed audiences, like some people who have a low understanding of the subject matter and some who are very advanced?
Mixed audiences, then the whole question is it speaking or writing? If it's writing, the simple answer to mixed audiences is to say, well, you've got two audiences, make two documents. But in fact, what I mean is you integrate that into one. It's just that there is one piece rather for the less specialized readers, and that would be the abstract the way I showed it here, and one piece for the more specialized. It's the whole idea of the executive summary, right? It's saying, well, the first thing everyone knows is a rather less specialized global view. And then those who want more can get more. Now, this is for writing because people can select what they read. Speaking, that's a little tougher because people cannot say, oh, I know that, let me skip, or I want more, let me go on. But you can do something equivalent if you say, well, okay, my time is limited. Let me give an even shorter than that talk. And I focus rather on the less specialized listeners, and I recognize that the specialists will not have had enough. But now I have plenty of time for questions and answers. So it's the closest you can make in a talk to the idea of appendices in a document. Is saying, well, let me not tell them details unless I know what details they want to hear, because I don't have time. So you give it rather non-specialized and then the specialist. That said, don't be afraid, as you give a rather non-specialized talk first, don't be afraid to put hooks. That is, parentheses about something slightly more technical that is going to make people, specialists in the room, say, oh, wait a minute, he knows a lot more about this than it seems. And that gives them ideas for questions. But make sure it doesn't cut the story. It's got to be something you open and close rapidly so the rest of the room can say, well, I didn't get that, but never mind, and they can follow the rest. Is this answering your question? Okay, there was a question here. If you can pass the mic this way.
Thank you for the great talk. My question for you is, how do you prevent over-explaining things when you're writing for a non-technical audience?
How do you prevent over-explaining things? Yeah. Oh, over-explaining is not the biggest danger. In general, when people have a problem with a talk or a document, it's not because it's too simple. It's usually because it's too complex. So one thing that is always useful in any case, even if it's not imposed by whoever you are publishing this with, is to put yourself a space limit. To say to yourself, I'm going to explain that in maximum 6 pages. That is the first way to force you to work your text again and again and again until it fits in there. But the better answer to that question, rather than this mechanical limitation, is to say, you've just got to make a test. You have to find people who are representative of your target audience, make them read a solid enough draft, and then see. And over the years, if you tend to write often on the same topic, you will be able to refine that, and in the end, you will be able to hit more easily what you are able to, what would be appropriate for the audience. But at first, if you don't know, ask. That's the short answer to that. Other questions? Yes?
Yeah, that was a fantastic talk. But I think you were kind of presuming that the audience is already predisposed to the scientific approach and the scientific worldview. But what about the situation where, as scientists, we are trying to convince people of that worldview, and we have an audience who's not predisposed? So, for instance, one example, I come from India, and even among the educated, very well-educated categories of people, there are people who, for instance, believe in astrology, or they believe eclipses are bad, or things like that.
Or they're not?
And so then, somebody characterized this as what you're doing becomes attacking their identity. So then, no amount of piling of evidence becomes sufficient. So then what do you do?
You are hoping for miracles, which would be appropriate because the question really touches on religion, right? This is the one thing I'm still struggling with so much, is the fact that people believe what suits them. They believe whatever fits in their own logic. For real religious things, for health beliefs, for lots of even everyday things, they would easily discard what are scientific truths, even though they're scientists, just because it doesn't fit in their view of the world. And that's a very tough one. Now, there are two things in the question. One of them is, can you make them understand your point? And the other one is, can you make it so they don't feel attacked? They don't feel like you are aggressing their values and so on, which you realize as soon as you touch on things that are religion related, and you easily get them when you talk about astrology and eclipses and other things, then it's really hard. Now, that also drives me crazy as a scientist when people present some scientific research and then conclude by saying, well, that's just this scientist's opinion, feel free to think differently. Now, I agree that many early research results are usually overstated, and first we think it's going to be marvelous, and then comes a disappointment afterwards because we need replication. At the same time, one thing that I sometimes do in those cases when people say, oh, yes, yes, but I don't believe in science. Then I tell them, do you have a cell phone? And they go, yes, of course, I have two, actually, a cell phone and a smartphone. Well, how do you think we could create that? How do you think we could create that? You say you don't believe in the scientific approach. Look what the scientific approach has created. It works. That doesn't mean it gives every explanation to everything that there is around us, and I have a few unanswered questions of my own, obviously. But that's at least a start when you want to show people, hey, it's easy to say I don't believe in science, but do you at least believe that this is working? But when it's getting really difficult, it's not offending them. And I don't have a surefire approach to do that. There are a number of ways, which is, first of all, doing whatever you do respectfully, which means don't aggress them, don't judge them, no good or bad. Don't interpret, don't say, well, obviously you didn't do that, you don't know. In the end, it is being gentle, but being firm in a sense, and saying, well, if you want to believe that, you believe that, but you're not going to convince me of that because I've got strong evidence with a method that has proven its worth that it's not the case. And sometimes you just have to agree to disagree and say, well, I'm not going to convince you, obviously, but don't think you are going to convince me because I stay on my position. Is that a follow-up to that? It's not a question. OK. Is this answering your question then? So I don't have a miracle to sell, but just keep believing in what you do and try to bring the discussion to a rational level gently but firmly. Yep. The mic is behind you. Yep.
So you already alluded to it in your presentation, which was excellent, that when you're communicating from a scientist to other scientists, you should follow these same rules. But let's turn things around and think, what would a layperson, a business person, an entrepreneur, a technologist need to do you think in particular, to be able to communicate effectively with the scientific community?
That's a good one. That's why I love doing these things. I get new questions. Bringing the discussion to a rational level is certainly a good way to get that one. If you believe scientists are rational people, which of course may be an overstatement, but for something at least they are. Now, if you at least focus on the last things that I had, which is the motivation and the interpretation, then you're in good shape because everyone cares about that. Even if you say, well, I'm not a scientist, I will not understand whatever they tell me, at least I can tell them what I need. And at least I can tell them after they do their work is if what they deliver to me answers my needs. So this is like when you do software programming and you first go and see the potential users and make a list of requirements. That's where the interface should be. Non-scientists would not have to care about the approach. They may want to ask, is this even feasible, and not believe that you're a scientist, of course you are going to make it true, but focusing on what is it I give to you so you can do your work, and what is it you give back to me at the end so I can apply that in my own work would be the interface that I see between those people. And then, of course, the obvious one, but you probably all know this one, again, mutual respect. Just showing that you value the other people who are different from you but have something interesting to share with you. If you don't have respect, then you don't have much communication. That's an evidence. You know what I propose we do, because I see time is running. Let me take one more question for the whole group. Then I will raffle the book and the booklet as promised. And then I will stay here as long as necessary until I have answered all the private questions. So don't run away. I have all the time in the world, but I don't want to keep you too long compared to the time. So that would be you for the last question. Don't forget yours. Make sure you come and ask it to me afterwards.
Thank you for the wonderful presentation. You mentioned in the beginning that the reason why scientists are often misinterpreted is that we're trying to impress our teachers to show that we're clever. So my question is, would scientists run the risk of appearing or being misinterpreted as being less smart or less knowledgeable if they try simplifying. Because especially if the audience is a mixed audience, and if there are specialists who are maybe even they know a lot more than you do. So do they run the risk of appearing as not as knowledgeable or not as smart if you try to simplify?
I understand, and that is one of the resistances to change that I meet is when people say, they show me a graph and they say, look, I put bars here, multiple bars, but you don't really see the trends. And then I make them a line graph with the same data, and you see the trends so well, and they end up saying, yeah, but of course this graph looks simple. And I go, yes, it wasn't that the idea. Yeah, but then, it doesn't look like I've worked much. So there's much concern about justifying the work done as opposed to the results obtained in the work. I would not worry a single bit, because what I observe at conferences in particular is that the keynote speakers that people admire are those who are able to explain in simple ways. But I have to pick on just one word you've been using because it's easily misunderstood. It's simplifying. I am not pushing you to simplify science. I am not pushing you to tell lies by saying, well, it's not really like that in reality, but I'm telling that to you because you're too dumb to understand something else. This is not at all the idea. I think of simplification the way you think of it with coordinate systems. If you're used to working in rectangular coordinates and you want to describe a circle, the equation is messy. If you use polar coordinates, then the equation to describe the circle is easy. But it's the same circle. You have not simplified the circle. So it's simplifying the expression of science that we need to work on. Find a simple way to express something complex. And if you do that, then you'll get incredible respect from your fellow scientists at conferences and so on. That's when people say, in fact, I knew what he said, really, but I would never have been able to say it the way he said it. And that's when you gain respect for the talks themselves, for the questions and answers afterwards. And we can make a statement and people go, hey, that's a nice way of putting it. That's where respect is, contrary to what you might believe. At least on the long term. Yes, you might falsely impress people on the short term by obfuscating your research, but I don't believe that's going to lead you very, very far. And many researchers that I know that have been the way of clear communication, they had a great career. So don't worry a single bit about that one. That's, again, a school reflex, a normal reflex, but it's still something from school. Okay, I think we've been passing out all the raffle tickets that we had, which probably was not enough to cover all of you. But so we will reward the early birds in the room. Give me a number between 0 and 9. 8. Give me a number between 0 and 9. 5. One more. 3. 2. Don't make a question out of it. So the number is 8532, right? Is that the winning number? Of course not. It's the seed that I need for my random number generator, obviously. So 8532 is what we had. And if I'm not mistaken, we had 96 of these. And so we got number 11 wins the book. Have we got 11 in the room, or is that someone who unwisely left? That would be you. And do we have 56 somewhere? That would be you. Congratulations, you win a book and a booklet. All right, again, I don't want to keep you, so I'm closing the session. But please, if you have questions, don't be shy. Come and talk to me.